Many of you have asked how gravity can bend space, and that's a really good question. So let's start with the observations, and then we'll move on to the interpretation. So let's start with the sun here. It's a big, massive object. And what would happen if, say, a rocket ship with disabled engines came drifting in towards the sun in some path like this? Well, we can imagine that the gravity of the sun would start to pull it in. Gravity of the sun would bend its path, and it could go careening into the sun, and that would be the end of the rocket ship. But what if the rocket ship came in at a higher velocity? Would its path be any different? Yes, in fact it would, because the sun would have less time to be able to change the path of the rocket ship. Remember, the engines are disabled, so this would apply to also to a comet or an asteroid or whatever. If it comes in faster, the sun is going to bend its path, but it doesn't have enough time for the sun to bend it all the way in, and it's going to go slingshotting around and out the other side. Now, if the rocket came in even faster, it would bend its path less, and it would maybe look something like this. Okay, so it turns out that it could be a rocket or a comet or whatever, doesn't matter even how massive it is. Anything coming in on a trajectory follows this path. The actual path is determined by its starting velocity. But apart from its velocity, nothing else matters. And so the interpretation here is that it's really an intrinsic property of space that determines how these paths are bent. And you could call it a gravitational field, but it turns out that even things like light that have no mass, and therefore, according to Newton's law of gravity cannot be affected by gravity, even those objects, their paths are bent like this. So it's really a good interpretation to say that it's a bending of space, and forget about gravitational force, everything has to follow the same path. So it's really a bending of space. And we can represent how that works here. This is the sun sort of bends space, so it's down like this. Far away from the sun, you see a flat space. And so if something comes near the sun, if it has enough velocity, if it has a small velocity, it'll just sort of go right down there. If it has a higher velocity, it'll get bent, but it'll come out the other side. I can't draw it in 3 dimensions, but you can see that its path will be bent, and it'll come out the other side. And this is actually validated by some pretty neat observations. Let's say Earth is on one side of the sun, and there's an interplanetary spacecraft on Mars on the other side. And so you're communicating with radio signals. It turns out that when they're on opposite sides of the sun, it actually takes a little bit longer for that radio signal to travel from Mars to the Earth, indicating that the light has actually dipped down into this gravitational well and back up, traveling a longer distance and therefore taking more time. So this bending of space really is a great way to interpret all these different observations. And the last thing I'd like to show you is, back to the case of the sun, if something is going really, really fast, it might be bent just a little bit. So a particle of light, a photon, may be bent a little bit like this. And a photon coming this way may be bent up a little bit. And so if there's some light source over here very far this way, its rays are actually going to be focused somewhat. And that's called gravitational lensing. Now, we call it a lens, but it's not a very nice lens like prescribed by an optician. It doesn't form nice images. And a good analogy is a wine glass. And if you take a wine glass and look down the stem, you'll see the distortions. There's, let's say, the sun. Some large mass passes between you and the sun. That's what the distortion is going to look like there. If it's perfectly aligned, you'll get a ring. Usually it's not so perfectly aligned and you get parts of a ring. And that's called gravitational lensing, and that's really a key tool in astrophysics for determining the masses of things.